Alright, in this section we're going to focus exclusively on arithmetic sequences and their sums. Alright, so what is an arithmetic sequence? It's one where the differences between the consecutive terms are the same. So if we had those a sub 1, 2, 3, and n are the first three terms, and then a sub n, then a sub 2 minus a sub 1, that's a difference between two terms, consecutive terms. That's going to equal a sub 3 minus a sub 2. That's going to equal a sub 4 minus a sub 3. And that value, d, is called the common difference. Common because it's the same every time. So if you have a function that's linear, but it's not really a function, it's a sequence, so the domain is positive integers, it's arithmetic. So linear and arithmetic, very similar. Like the slope stays the same. You could kind of think of it that way. Alright, did not mean to do that. So, sequence 1, 4, 9, and 16. The formula is n squared. Show why it's not arithmetic. Well, the definition of arithmetic means the common difference, or the difference is the same between any two consecutive terms. So all you have to do is find like the second and first term and subtract them, and then the third and the second term, subtract them, and show that they equal the same thing. So just like with lines, when you have 2 points, you could write the equation of a line. With arithmetic sequence, or back to lines, if you have the slope and like the y-intercept, you can write the equation of the line. Same thing with arithmetic sequences. If you know any two terms, or if you know the common difference in the first term, you can write the nth term formula. Alright, and this is what we're going to use right here. Oops, wrong slide. This is what we're going to use right here. Alright, so this is the nth term equals the common difference times n minus 1 plus a to the first power. Alright, it makes sense if you think about it. Let's say, alright, let's just plug in 1 for a second. Alright, so on the first term, n is 1. Well then, this would equal 0 times d plus a sub 1 is equal to a sub 1. Alright, let's say we add a sub 2. Well, we'd plug 2 in here, so it'd be 2 minus 1 times d is d plus a sub 1. So it's like, alright, the first term plus the common difference is the second term. That makes sense. Alright, and let's say it was like the third term. So the third term would be 3 minus 1 is 2 times the common difference plus the first term. So, alright, to go from the first term to the third term, you add the common difference twice. Alright, so that's why the formula makes sense here. So you could plug in the difference, or the term number, or the first term, or whatever the value is at whatever you plugged in for n, to help you find a sub 1 and a sub 1, a sub 1 and d if needed. So let's try it. In this first example, let's write the formula for the nth term of an arithmetic sequence whose common difference is 3, whose first term is 2. So this one's easy because they give us the first term and the common difference. So if the formula is a sub n equals d times n minus 1 plus the first term, we could just plug in, it says, alright, the common, oops, I switched slides, sorry. Okay, so back on the right slide, and I wrote the nth term formula and plugged in the common difference in the first term. So that would be the formula. Now it's always good to write it by distributing the 3 and then kind of simplifying it down like this. That's a better way of writing it. Alright, and what's great about this is, alright, now if I wanted to find out like what the 10th term was, I could just plug in 10 for n, and I could see it's 29, right, without having to do, alright, 2, and then plus 3 is 5, so that's the second term, and then plus 3 is 8, okay, that's the third term, all the way until I got the 10th term. With this explicit formula here, you can just find any term by plugging in n.